Okay, let's do another example. Again, we're trying to just find the reference angle for each one of these. All right, so next let's work with 47 pi over 4. So first of all, where is that? Are we too big? What does this mean? So 47 divided by 4 is 11.75. That's way bigger than 2. This is bigger than 2 pi. So we need to subtract some 2 pi's to get to what we want. All right, so 47 pi over 4. I actually need to subtract 5 2 pi's. One, 2, 3, 4, 5. Yeah, to get what we want, 7 pi over 4. All right, so I did it fast because I already knew. All right, so 7 divided by 4 is 1.75. Perfect, that is less than 2. So we have less than 2 pi. So this is 1.75 pi. Okay, so what quadrant is that? 1.75 is between 1.5 and 2, so it's in quadrant 4. So here is the angle that we're talking about. Starts here, ends in quadrant 4. The angle we want to find is this little bitty reference angle right here. We want something less than pi over 2, or less than 90 degrees. How do we get it? Well, we take the full rotation and then subtract this angle. So 2 pi minus 7 pi over 4. All right, and so we would do a common denominator. 8 minus 7 is 1. So our reference angle is pi over 4. All right, last one. So we have our angle is negative 7 pi over 6. We already know that's not on our circle because it's negative. So let's add 2 pi to get us on our circle. Common denominator. Negative 7 plus 12, that's 5 pi over 6. Okay, so negative 7 pi over 6 has the same location as 5 pi over 6. 5 over 6 is about 0.8. So we can figure out exactly what quadrant that's in. 0.8 is between 0.5 and 1, so we're in quadrant 2. So we are talking about an angle that starts here, ends in quadrant 2. What we're asked to find is this little reference angle. All right. So that means we need to take this angle, subtract this one, and we'll have our reference angle. So pi minus 5 pi over 6. And we get pi over 6 as our answer. So that is our reference angle. Okay, so why is this useful? Why do we go through learning how to do this? Well, sometimes you may not know the unit circle, and you may just know our special angles. So these reference triangles is what we're going to be using. Okay. All right, so my little note says, let theta be a non-quadrantial angle, so not on the x or y axis, in standard position. Find the value of a trig function at theta. Find its reference value for the angle, so our reference angle, and then prefix with the appropriate sign using all students take calculus. Sounds like a lot, but there's a little method to this process. All right, the first thing that we need to do, so let's see, the question is determine exact values of sine of 2 pi over 3 and cosine of 2 pi over 3. Okay, first of all, 2 pi over 3 is not an acute angle. It's bigger than 90 degrees. All right, so the first thing we need to do is figure out in what quadrant is 2 pi over 3 located. Oh, I can't spell. Quadrant. All right, well, 2 over 3 is 0.6. So this is in quadrant 2. Okay, so that means here's what it looks like. What we want to figure out is our reference angle. So that's what we're going to work on next, finding our reference angle. All right, so we just discovered how to do this kind of thing. In order to find our reference angle in quadrant 2, we're going to do pi and subtract 2 pi over 3. And we get pi over 3. All right, so this is good because this is an acute angle and we have a special triangle for this. All right, so we can find sine of pi over 3 and we can find cosine of pi over 3 using these triangles. All right, so remember 60 degrees equals pi over 3, 30 degrees is pi over 6, 45 degrees is pi over 4. So we can find sine of pi over 3 opposite over hypotenuse and cosine of pi over 3 adjacent over hypotenuse. Okay. So we have sine and cosine of our reference angle. Next, we want to get the actual answer to the question we were talking about. We want to use all students take calculus. All right, so the reason we're using reference angles is because they're going to give us the same trig function values that we want. So sine of 2 pi over 3 is going to be the exact same thing as pi over 3. However, the sign may be different. Okay, I'll come back and do the signs in a moment. So cosine of pi over 3 is the same as cosine of 2 pi over 3, except the signs may be different. All right, so we are in the second quadrant. All students, so that means sine is positive, which means cosine is negative. All right, so this seems like a lot of work. That's why we have unit circles. Let's check our answer using the unit circle. Did we get the right thing? Well, here's 2 pi over 3. Cosine is negative 1/2. Sine is root 3 over 2. So using reference angles is an alternate method to the unit circle.